Is Jay Mezer. I'm a solutions consultant here at IMAGINiT. If you were here last week, you kind of I went through the whole deal of who I am. I've been with IMAGINiT for 15 years now. I'm a civil 3D professional, and I've been working with the RCS team, as we call it here, for about 10 years now. So I've kind of had the, the opportunity to see a lot of different projects and work on a lot of different projects. So hopefully, if there's any questions you have, I'll be able to get those answered for you as we go along here, or I should say after the presentation. So today we're going to start, and as Gladys mentioned, we're going to talk about processing point cloud data. We're going to talk about implementing reality capture into your workflows and maintaining a secure environment throughout the capture, storage, and sharing of our data. So to begin, let's talk about what we need on the software end of things. And last week we went in through the scanners and we talked about the different scanners and kind of how they operate. And we didn't dig as deep into the software that it takes to process data. So no matter what type of scanner you use, more than likely it's going to require some sort of registration software. That software is, for all intents and purposes, a stitching software. And what that means is to register means to stitch our point clouds together. So each individual scan setup is an individual scan until it is registered or stitched together. That allows us to create a full 3D environment and therefore have an entire point cloud of the area we wish to scan. All right? The data must be imported into this registration in a variety of formats. Those formats can be native scanner formats. In the case of Leica, that could be an RTC 360, a BLK 360, or they could be imported in more generic formats, such as an E57 file, or even in some cases, competitor scanners are able to be imported into Leica software. So no matter what scanner you go with, these are things that you should be looking into as to what data can I bring in? What if I go with another scanner? Or what if I'm supplied with other scanner data? Once the data is imported, it has to be reviewed and optimized. And what we mean by that, each one of those, in that picture you see there, each one of those green lines is referred to as a registration link. And that link is expected to have a certain amount of error. In other words, one scan isn't going to have the same exact data that the other scan has, and therefore that would cause us to have a slight amount of error. And of course, we try to get that error as low as possible. But we have to review the data when we import it into the software to make sure that our data is registered as tight as it can be. You see in the box on the right of the image there, the amount of error I have, the amount of overlap I have, and the strength of that overlap. Right? Now, I'm often asked what is acceptable right here in this error or overlap or strength report. And that entirely depends on your company's standards and how much error you're willing to allow. When we finish reviewing and optimizing and possibly even cleaning that data, we then want to publish that data out to one of several different formats to meet our needs. And those needs could be anything from just shipping the data to a stakeholder in that project. It could be something like sending it to an engineer or an architect or a designer to be able to pull measurements from. And so we need to know what that data is going to be used for and where they're going to use it in order to publish the data out of that registration software. The questions we might ask is, where do you plan on taking the data after I hand it to you? Is it going into a CAD environment? Is it simply being reviewed where I could supply you with a free viewer? Or do you plan to import it into some other software that maybe doesn't typically import point cloud data? And in any case, there's more than likely a format that you can publish out to get into any of those different scenarios. Okay? So then we want to talk about implementing reality capture into your workflows. And where you need to begin here is by finding your use case. And what we mean by that is, or what I mean by that is, what type of data are you going to scan? And if you're going to, let's say, scan a civil project where you want this to be complete survey grade, you want to traverse and follow a survey workflow with your scanner, we need to know that. If you're talking about possibly going into a manufacturing facility and where we might have some sort of stainless steel or something like that, we would need to know that. If you're scanning simply buildings to get walls, doors, windows, locations of all of those things, again, we want to know that. That helps us find the right equipment for those types of projects. The next thing we want to talk about is calculating your return on investment, right? Am I going to use this scanner once every year? Well, it's going to take quite a long time to get that return on investment to use it just simply one time a year. More often than not, we find that people aren't using it one time a year. They're often going ahead and saying, oh, well, I have this use for it. And as soon as they get the scanner, 6 other things come up where they say, oh, I could have used the scanner on that. So think about all of those things and how often you're going to use it. How many people are you sending out to measure a particular project, whether it's on your site or whether you're sending them through the air or on a bus or whatever. Figure out how many people you're sending out there. And let's say you're sending maybe 4. Well, that's 4 people measuring a project, when oftentimes a scanner could be done with 1 person. So again, calculate that return on investment. And more importantly, find the correct hardware. I already mentioned this a little bit. It's so important that we get the right hardware in your hands for the types of projects that you're looking to create or to scan. Okay, so if you simply say, I want a point cloud, how accurate do you want that point cloud? And if it's, well, I need a general idea of what's in a space, well, the scanner you might choose that's on the screen now is the one in the center there. If you're telling me I'm going to scan some small buildings, maybe a little bit outside, you might choose the scanner on the right. And if you're going to do larger projects where things need to be done quickly, accurately, and all registered in the field very quickly, you might choose the scanner on the left. And then probably the most important part of implementing reality capture into your workflows is get the training for scanners. Oftentimes we hear people will buy a scanner and they buy it from one of them, a lot of different shops out there who will simply order the scanner for you. And when it comes in, they'll hand you the box and they'll say, here you go. And if you already know how to use it, that's great. But if you don't know how to use the scanner, it really takes somebody knowing this inside and out to show you how to get started. So get the training, learn how to use the hardware, learn how to use the software. And then, of course, learn how to get it into whatever environment you want it in, whether that be a CAD program or simply a viewer to review the data. Another thing that's really important as you're planning to get into reality capture is to plan for large file sizes. One of the things I hear quite often is, whoa, we weren't ready for the size of the data. You know, most people are used to dealing with a Word document or even an AutoCAD file where that might be several megabytes, maybe a couple hundred megabytes. If it reaches the gigabyte level, that's kind of like extremely large. Well, in the point cloud world, remember that we're collecting millions and millions of points. So we often start in the gigabyte section here and pretty much play in that playground the whole time. It's not too often we get above the terabyte. It does happen, but it's not too often that most people don't get that large. And then one of the last things is plan for ways to share the data. That might mean that you're taking the data and you're sending it from a hard drive and putting that in a FedEx or a UPS package and sending it. That might mean that you're publishing the data to the cloud. And I know we're on a government call here. That doesn't happen often that you rely on the cloud, but you know, some people do. And then others simply might be, hey, you know, I'm gonna share this through a Dropbox, or I'm gonna, again, just simply mail something to you. And so then let's talk about, you know, things we have to plan for. Now let's talk about challenges faced. A lot of times we're sending 3 or 4 people out and going around the globe to measure one project. We don't have to do that with the scanner. We can often send 1 or 2 people out to scan an entire project and come back with that data to share with the rest of the group. And so this is a reason that we go towards scanning, so we don't have to send all of these people to get 3D measurements. And that, of course, plays into time. Having 4 people out of the office for a certain amount of time is really tough. And not only having them out of the office, but having them out of the office for a stretch of time, right? It's taking 4 people much longer to measure a space than it would be for that one to finish with a laser scan. And then, of course, they come back and those measurements either are incomplete or incorrect, right? And if that's the case, you know, hey, people are human, they make mistakes, or not even mistakes necessarily, just simply didn't realize they needed a measurement or didn't plan to get that measurement. So what does that lead to? Site revisits. Now we're sending them back to the field to pick up the measurements that we didn't get the first time. And if you were on the call last week, and you'll see a little bit later today, you know, that often means that, hey, look, we have, when we scan, we have just an abundance of data that sometimes the problem isn't that we missed data, it's that we collected too much. And better too much data than not enough. We can always get rid of data we don't want. Right? And so some of the reasons that people shy away from going towards scanning are, why are we doing it this way? Why are we doing it the current way we're doing it? Let's think about that. And then the answer is usually, it's the way we've always done it. And this one drives me crazy. Just because you've always done it this way doesn't mean you should. So the question then becomes, why don't we change? Simple answer is nobody knows. We don't know. Just kind of revert back to answer one. We've always done it this way, right? Sometimes it's just simply because we're too busy. And that happens. People know there's new technology out there, but it's too hard to use. I've heard this one so much. And it's really not hard to use. In 2 days from a class from IMAGINiT, we can have you up and running on your hardware and your software and doing it on your own. Sure, you might have a question or two after those. But most often, people don't. They're running it on their own and getting point clouds and working with those point clouds. And then another one that I often hear from people is they don't have time to learn something new. To which my answer is kind of like, blah, blah, blah. You don't have time. You're already spending the time. Just not in a way that's as productive as you could be. So I lean back to what I said earlier, back to training. And so how can reality capture help you? It's fast. It's accurate. Risk mitigation. We're getting much more accurate measurements than what we're getting with a tape measure. Right? And if you watch the video here, this is what the RTC 360 looks like when it actually starts to go. Yes, that is how fast. This video is not spun or sped up at all. So this thing is moving and collecting data. 2 million points a second. And of course, the ending of this is we give our designers, our engineers, working knowledge of the project. And like I always like to say, we're able to put those people inside the project or at the project when they don't even have to go for a visit. They can look at the entire point cloud. So how's reality capture help? Time savings, money savings over time. Sure, equipment and training and software can be expensive at the forefront, but after that, we're making money on our investment. And so let's talk about getting started. I mentioned earlier the hardware. Not all scanners are created equal. I did some examples about the different projects. I won't harp on that. Like I mentioned earlier, my saying is there is a right tool for the job. Let's make sure we pick that correct tool. What types of projects? I gave you examples of those types of projects. What materials? If you have questions, talk to us. Call your IMAGINiT sales representative. We'll be more than happy to help you. And then we get to the software. I mentioned the registration software. There's a publishing software now has been renamed to Cyclone Workflow there on the right, but that allows us to get into a file format that we can use to somewhere for something else. File storage and sharing. Like it has a product called Cyclone Enterprise. There are different products out there for different scanners. I'm using this one as an example. This allows us to take our point cloud data, store it in a location on site, meaning at your facility or another facility that you're connected to, and allows us all to share that point cloud data. So everybody can have access to it, and individual people can be given rights to that data. We can take and model from that point cloud data. If you're a Revit user, or even if you're a person who likes to create a 3D mesh, we can create that 3D mesh from point cloud data using Cyclone 3DR. All right, maintaining a secure environment. One of the things that Leica has come up with on the RTC 360 is our ability to create a digital signature to our scan data. There's security built into the hardware for this. You can use the data within your network or on a specific computer. And again, I know we're with the government agencies here mostly, so cloud computing doesn't necessarily work, but I put it here just to put down that it does exist where that Cyclone Enterprise tool I mentioned can be run on AWS or an Azure site. Okay, and so what I'm going to do is, I talked about these last week, I'm going to pop over and I'm going to look at some data here in the Register 360 software. Now, I showed this last week as well, so I'm going to go a little bit more in depth here when we talk about this. And what you're looking at is all of the scans that I did for this particular bridge project. Now, each individual red dot is a location where I set the scanner, and then, as I mentioned earlier, each green line or registration link is connecting those scans together. And again, as mentioned earlier, I have a certain amount of error. Now, for those of you who might be wondering, is there a way that we can see this in imperial units? Absolutely. We can see that the amount of error that I have for that particular link is 1/16 of an inch, right? And so when I look at the entire data set, my whole thing here is at 1/8 of an inch. So that's pretty darn good. If I then look at my point cloud in 3D here, again, like I mentioned earlier, I'm able to put somebody in the environment without them actually going to the site. And for those people who might have a hard time kind of putting into their brain this point cloud information, they do better with picture data. Of course, we can add that too by going into what we refer to as a setup cloud. And these are the pictures taken from the scanner. Now, I can keep clicking, going on from red dot to red dot here, and you can see that I'm now under the bridge. And if I so choose, I can change my image data so that it turns on auto brightness, and you'll notice now that the picture quality is a little brighter. This is because of a camera setting on the scanner itself. It actually allows me to adjust the amount of light in my scan. So we can see that I can see under the bridge very well, but one thing I can't see is I can't see out the other side, obviously, because there's a lot of light coming in there. If I drag my brightness here, notice the detail I can now see on the other end of that bridge. And this is all because of HDR cameras, or high dynamic range. Now, if someone who collected the data, let's just say for fun that someone messed up, they really kind of screwed up and they forgot to do registration in the field, right? That's fine. We can come in and we can always edit any of that registration so we can compare our 2 point clouds. Now, if you look at this data, you might be thinking, well, wait a minute. There's 2 different colors here now, and there's no tree data around it. That means that I went in and I said, I don't want to use the tree data to register with, because what happens when trees blow in the wind? They move back and forth, right? So they're not good for registration purposes. I'm only using the bridge here. So I can take one scan and simply move it over top of the other. And I'll zoom in here so we can see it a little bit better. And I'm going to move it right here-ish. Sure, let's call that good. And now I'm going to look at it from the side. Does it line up vertically? Yep, looks pretty good to me. Just do another quick check. Yep, looking pretty good. I hit join and optimize, and off I go. Those 2 scans are now joined. So even if somebody were to make a mistake in the field and not be able to register that data like we looked at last week, we can do it here in the office. If we want to, we can also come in here and we can say, boy, these trees, they're really giving me a headache. I don't really want to see them anymore. I can always, well, let me go like this first. I can always come in here and decide that I want to clean this up temporarily. Whoops. And I can start pulling this in a little bit, or possibly even spin this cube. And now you'll see that as I edit the cube here, I'm pulling in data maybe that I don't want anymore. Right? Oops, I probably went a little far here. So now it's pared down to maybe just what I want to see, and I can turn that cube off. Oh, that's not what I want to see. But now you can see the water below. If I want to turn that off, I simply turn that whole cube off. Or if I wanted to get rid of things kind of on a more permanent basis, and by permanent, I mean semi-permanent, I could always draw a shape around the area that I might want to keep. And tell it, I don't want anything outside that area. And this is going to go through and remove all of this stuff outside that highlighted area. Apparently going to take just a moment. And so while that works, I'm going to move on here, and maybe I can come back to that in just a few moments. And so when I'm done with all of this, I can push that data out to a variety of different formats. It can be an LGS file, it could be an RCP file if you wish, and then ultimately I can bring data over into something like Revit or possibly Civil 3D or AutoCAD, whatever your flavor is. I can go ahead and open a point cloud in something like Revit. Bear with me just a moment. My computer decides to wait a moment. There we go. And I'm going to grab a Leica-based file to import into Revit here. And you can see that now I have my point cloud data in Revit. I can take and adjust if I need to, some levels real quick. I'm not going to get too worried about this. But what does everybody want to do with something like this, right? They want to be able to pull out floor plan information or something like that. So I might come in and tell it, hey, I want to get some floor plan information. And basically what I've done here is cut a very thin slice through the entire point cloud. And so I can use a floor plan tool to then adjust the thickness of that slice. And I can start, and I'm not going to get too detailed here because we just have a short amount of time, but I can start clicking and, whoops. All right. And we'll go up here and here. And we'll just say close, right? And then I can send that to CAD and say go from level 1 to level 2, pick a wall type, and let's put it on the left side, and we'll click OK. When I get rid of this window, over in Revit, I have 3D wall data. And then, of course, we can take that even further if I get rid of that for a moment. And we can clip out just a small section and take a look inside this facility where I might be interested in something like this, where I can create pipes. So the CloudWorks for Revit has a pipe modeler. So I might come in and say, let's model some pipe. Actually, let me just go like this. And I go to the pipe modeler, and I got a lot of bunch behind this. I meant to get a little less, and now I'm modeling pipe, and I say finish, and you can see that I've started to get the beginnings of modeling this pipe run. And so if I say save piping, you can see the center lines of the pipe here. And if we close that, of course, and go to a more defined detail here, you can see there's my modeled pipe. All right. So one of the last things I want to show is just talking about storage and what we can do with storage. So I'm going to pull this over. This is my web browser. Leica has a product known as TrueView Cloud, where they manage the data. You upload the data, and if we, of course, log into this, I can take a look at different sites. And just like the site I was just looking at, right, I can go ahead and click on an individual scan, and hey, that's that same site I was just looking at. And so again, you can kind of put somebody there and you can share a URL to this and be good to go. Now, they also have a product known as Cyclone Enterprise. And Cyclone Enterprise allows us to take from different types of projects and take those projects and store them within our own environment and go ahead in and look at them. Now, keep in mind that this is, you'll notice that this is a point cloud with modeled data, right? So somebody built the walls up here, and we can take a look at all of this right here through a browser. Now, I want you to keep in mind that this data does not reside here on my computer. This is on a server in another IMAGINiT office somewhere, and I'm actually streaming the data as if it were a movie. And so we can go from one project to the next. Oops. Right, so this is up, of course, in the ceiling, and I can even switch this into 3D point cloud mode, and I can navigate through one of our training labs. And so all of this is possible with the different tools that are out there in reality capture. And of course, this being within my network, it's secure. The only way I can get to it, of course, is to VPN into this, into our network, and be able to then stream my own point cloud data.